Now I would like to present with a bit more detail HISER project. HISER project is the reason that we are here today. We are almost at the end of the project. This is a 4-year project related with construction and demolition waste. This is a common topic because all those issues of circular economy and a relevant topic for all Europeans, since construction and demolition waste is 1/3 of all waste generated in Europe. This project wants to answer some European challenges in the construction and demolition sector. Those 3 ones: the need to move towards highly efficient paradigms of recovery of valuable raw materials. That's why we decided to organize this event together with the European Raw Materials Week. The need for progress in novel recycling technologies from complex construction and demolition waste. Today we will present some of those technologies that have been developed and demonstrated in HISER, both at lab scale and at demonstration case studies. The need for novel solutions, stimulating selective sorting as source of materials arising from demolition and refurbishment works. Again, in HISER, we are totally agreed that we cannot efficiently recover raw materials from demolition waste if we not identify them previously, if we not separate them on site. So we present a couple of tools with 2 solutions that have been developed in HISER. This is when I have 2 minutes or 5 minutes to summarize HISER, I use this picture. We simulate the full life of the buildings, and we develop some solutions for each stage. For example, before the selected demolition, there are some solutions that can get more accurate information about the quality, the contents of the materials inside the building. And also they can help us to guarantee the traceability of those materials from the building to the final application. Later on, when we have the materials recovered from the building, we have work on different technologies for more efficient sorting of those materials, automatic sorting using sensors like that will be presented later. Also technologies for quality assessment in line with other applications, in order to create construction that can be implemented in the real market. And finally, as a 3rd part of solutions, we have the development of new building products incorporating significant amounts of recycled materials, just to demonstrate that those materials have value in the market. So, this is the agenda for today. You have a copy in paper in your chair. So I will start directly with the first result, with this about one solution we developed in HISER using BIM technologies. I suppose that all of you are familiar with building information modeling. We strongly believe in the industrialization of the construction, and one of the legs for the table of the industrialization is the building information modeling. Yes. So, first of all, look around you. Look at this beautiful room. Can you imagine, can you quantify the amount of materials that will arise for this room if we decided that it's going to be demolished? What will be the quality of those materials? The volume? The different connections between materials, between plasters and brick wall, for example. It's quite difficult, but this is a... Can we pass to the next presentation? Presentation number 2? Yeah, thank you. So when we arrive to a building that is at the end of its life and is going to be demolished, we have several questions that must be answered before starting the demolition project. What are the materials? How are they connected? Where are located? What are the size? Is there any reusable element, any valuable element? And a very important one, is there any hazardous material? Asbestos? Any other? So, In the real life, when we arrive to one of those buildings, most of the time there is a lack of information. We have information in the shape of plans or drawings, but most of them they are not updated. We have information from photos, from literature descriptions, but they do not provide quantitative information. So at the end, the techniques, the expert, the auditors, should take manually the measurements to investigate the different construction typologies, the different materials that are inside the building, which is quite time consuming. But not only time consuming, because at the end everything takes time, but the quality of the data obtained in that way sometimes is not good enough. Another issue is that when we are preparing a pre-demolition audit, the work before the demolition project, we need to get an idea of what is inside the building. So in that way, we will know which is the best procedure for separating those materials, for stripping the building, for selecting the most efficient select demolition process. Here we have a document prepared in collaboration with VTT about some guidelines for preparing those pre-demolition audits. If we put all this together, we know that there is a lack of information, but at the same time we need to quantify in a certain way what are inside the building. So this is why we decided to use building information modeling. This is great because with this working method, not just the software, we involve all relevant stakeholders. We can analyze the building from the full life cycle, and we can generate a virtual model of the building with not just the geometric information of the elements, but also some additional information that can be used for obtaining more accurate data about what is inside the building. So when we arrive to one old building, the problem is that there are no drawings, so there are no models, and models takes a lot of time. We digitalize the main entities of those buildings, but just at a basic architectural level. So we must identify if a certain piece is a wall or a column or a beam, and later on the demolition auditor will say what are the type of that element and what are the composition according to some databases. There are different techniques for capturing reality. In HISER we have used 3 of them. The first one is the traditional, take hand measurements and go then to the laptop, to the computer, using a CAD software, and from that CAD file we can generate the BIM model. Another option is the 3D scanning. Using some laser scan, we can localize all the different dots in the surfaces, in the visible surfaces of the building, and with these point clouds we can get an additional support for generating the BIM model. Also, 3D photos and photogrammetry are additional solutions, but after a deep analysis we realized that 3D scanning at this moment is the best solution. But after this we only have the same result, a BIM file, which is a file in IFC format, with this aspect. I cannot read anything, so probably neither you. But in this file we have information with this type of code, including the geometry, the properties, the quantities, and the classification of each of the elements inside the building and how are they connected. Then we can use different softwares to visualize that BIM file and help us to inventory all the different parts. So this is the aspect when we have inventoried while building. This is a BIM model for a building existing in Tecnalia, but I'm going to use it just as a model for explain the different stages for using our tool. Our tool is composed of 2 different parts. The first one is used for inventory all the elements. So starting from the preliminary IFC file, we are able to inventory each of the elements using both the 3 list or the 3D graphical representation of the building. We can just click, select one of the elements, and inventory each element in this way. We have extensive database with 4 different levels from the top category of the element, beam, column, floor, window, door. We can select the type of element and 2 additional subclasses, so we can get an accurate definition of what is that element. Then when that element is defined, the tool provides some generic data, some let's say standard data for the properties of that element, including density of the materials, main values for the geometry. Imagine you have a door and an inner door. Automatically the tool will suggest you to use some mean values like 2 meters high, etc. But those values can be modified by the demolition auditor. So we can get very accurate information, very accurate results, but spending time on the definition of those elements. We can also check which is the inventory status of our building, and we can select if some parts of the building are going to be maintained, for example, for rehabilitation projects, which are also a typical activity of the construction sector. So, in addition, we have another tools that can be used to accelerate the inventorying of all our elements. With all those information, we move to the second part of the tool. We have inventoried all the elements, so we have an estimation of what is inside the building, but then we need to define what will be the demolition process. And according to our decisions, we will get different waste streams. So here, I'm sorry that it's difficult to read anything, but we can create the groups of elements. We can define how will be the demolition strategy for remove or demolish those elements, and in that way we will get different waste streams. For example, if we have a wall composed by plasterboard plus brick wall plus an additional insulation layer, we can decide to demolish all together because we don't have time and nothing is watching us. Or we can decide to separate first the gypsum plasterboard, remove manually the insulation layer, and demolish the drywall. So in that case, we will get 3 different waste streams, and the software can consider that. The final outputs of this tool are a huge definition of what are the waste streams, in which amounts, in which volumes, considering also some volume factors, for example, the volume factor depending on the demolition process, also the humidity content to update the weight of the materials, and also some indicators regarding what is the energy and the materials recovered from our building. We can report all that outputs in a PDF file that can be annexed to the pre-demolition audit as a suggestion with this look, including the results by groups of elements, by waste materials. All this according to the European list of waste. So we will have the codes, we will have the names, and we will have the definitions and the origin of those materials. So that guarantees a lot of traceability. That tool has been also integrated with a commercial tool, because our intention is not just to generate a tool for ourselves. It's a tool that must and is being used in other projects, at least in Basque Country region is being used in other demolition projects. And inside HISER, we validated and integrated with the commercial software, with Rhino. I don't know if you know Rhino 3D. It's a software. It's a specific software for the building projects. But here we can increase the capacities of our tool, because we can also generate some Gantt charts considering the different links between the demolition activities. So we can generate demolition alternatives. We can generate different the demolition projects, and we can check them from all the perspectives, not only the environmental one, but also the timing, the economical one, etc. And at this moment, well, in fact, it was finished some months ago. We are reporting it now. We have demonstrating this tool in several case studies from different typologies. The first one is an old train station in Basque Country. The second one on the left is a living house for 2 families in Poland. And this is a complex, it's a simple building but with complex materials also in Spain, property of Acciona. So we have obtained the IFC files of those buildings from different methods. We have applied traditional and our BIM selected demolition tool for quantifying the waste streams, and here are the results. We increases a lot the accuracy of the estimation of the waste streams. There are some tools provided by the administration, but those tools estimate only for a few parameters, so the deviation can be as higher as 400%. And with our solution, we keep, in most of the cases, that deviation less than 25%. So we get a lot of accurate information, which is also good for the future steps. The major problems are with that both capturing of the reality and inventorying is quite time consuming, and as you know, in demolition sector, time is gold. When demolition companies attend to the buildings, they have just a couple of hours sometimes to take an idea of what is inside the building. That's why they cannot prepare and compete in a reasonable way, because they are doing very rough predictions, not accurate at all. But we think that in the next future we are still working after HISER to use the new plugins and the new technologies to include additional capture of the reality and automatic images recognition to accelerate that process. So as I told you, apart from the case studies developed in HISER, we are still using that tool for new demolition projects in order to get more information about it. Thank you very much. Do you have any questions? If not, I will pass the floor to the next. One question there, yeah.
Can you, with your tool, automatically recognize what's inside the wall? If it's brick, concrete, wood?
No. That's the short answer. But no, it's not possible. We try to analyze different alternatives, different technologies, even for identify piping or other installations. And the existing methods are not feasible. Sometimes they are not accurate. Sometimes they are not. Most of the elements are covered by a layer of gypsum, paintings, covering layers. So it's very difficult to use that to get that information using existing technologies. So what we have done here is to capture and to recognize the general class of the element, a wall, and then using the databases we can specify what is inside. So we replicate the standard demolition audit process, checking which is inside the walls, breaking them a little bit. The good thing is that once you have inventoried one wall, you can we call it a spread. It's just a copy and paste option to all the all the walls in the building, all the walls in the same floor, using different options, so we can implement that information very quickly.
Basically, you're assuming that the whole building has the same wall characteristics.
You should check first, of course.
Yeah.
That you can. I was trying to explain that once you have validated that all the inner walls are just a 9 centimeter solid brick wall with a 1 centimeter layer of gypsum, for example, you can copy that to all the walls, inner walls of the building, and then modify if one have an extra layer or insulation or other material. Yes, please.
Brian James from UEPG. Brian James from UEPG. Two questions. One is, with the information that you are generating here for future use, how does this take account of changes in technology when the building or structure life is going to be somewhere between 50 or 100 years? And the other question is, when I saw pre-demolition audits, does that take into account the protocol that is already in existence?
There are two things. Well, the first issue is that this tool is an autonomous tool. I mean, we need the IFC file of the building. If this is a building with an existing IFC file, as all buildings in the future should be, we can use the same tool for those buildings in the future. We need to update perhaps the data list, the database of the elements of the materials, but we can still use the same tool for buildings in 50 years. Perhaps we need to upgrade the tool, but the procedure can be exactly the same.
Right. Traditionally, records of buildings have been lost within, 5 to 10 years maximum. I personally have a lack of confidence in that in 100 years' time, anybody will be able to access this information because technology has changed so much.
I don't know if I catch your question. With these IFC files, the information inside there can be read by different softwares. So even if the model of the building is prepared for this tool, that the same IFC file can be read for different softwares. The information is accessible. I don't know if I catch it totally right in your question.
But the other question
was
was the pre-demolition audit, and have you taken into account the protocol that has been developed and is in operation already?
Yeah. There are two parallel documents for the pre-demolition audit. There are some guidelines. It's not any law, any compulsory document, but we developed some guidelines together with the BTP. And here we include. Thank you. For reporting the results of this tool, we follow the recommendation both from the waste management protocol and the demolition audit guidelines.